get going here.
Yeah, Javier, I guess feel free to take it away. I see a good number of participants dialed into the Zoom and online, about 12 or so. So yeah, whenever you're ready.
Okay, great. Okay, well, thanks everybody for showing up for this AskTOM session. So first I'd like to introduce myself. My name is Xavier Lopez. I am product manager for Oracle Spatial and Graph products. Joining me for this session for AskTOM will be Alan Wu, who's waving there. I'll be doing the demo, so he'll introduce himself a little bit further when he kicks into his demo section. And Gene M also on the spatial and product team there. So first, I'd like to take care of a couple of housekeeping items. So once again, this is an AskTOM Office Hours session for Property Graph. So we'd like to hear more, we'd like to provide you a little bit more each month about some of the things that we're doing with Property Graph, some of the new developments and new directions, but also more importantly, we wanted to be able to take your questions. So this is an opportunity to ask questions on this topic. So we'll start off with a short presentation. So I'll do a short presentation on some of the agenda items here, the graph database concepts, use cases, and some of the features. So I'll take some questions at the end of that, but if you've got something dying, please put that in the chat, and then we'll take those questions as we have time there. Then we'll transition into a demo. Ziyu will give you an example of some of the applications and what you can do with the property graph, what our customers are actually doing as well. So we've got your lines muted, so please use the chat to ask your questions. And remember, we can't discuss any SRs or bug reports or licensing issues. Also, if you post code into the chat, remember that everyone can see it unless you direct it specifically to the host. So let's begin. So we'll start off with a little bit of an overview on the products themselves. So this is the Oracle Spatial and Graph product. This is for the database. That's really what we're going to focus this particular session on. We're going to just focus on the property graph support for the database. This was introduced 2 years ago. It also has an RDF graph feature. We won't go into discussion on that in this topic, in this session, but we just want to let you know that that graph data management capability is there. It's been there for about 9 to 10 years now on that. On the right side, we also have property graph capability on the Oracle Big Data Spatial and Graph. So this is basically to support those customers that want to provide or that need graph analytics, graph data management, but are running on non-relational systems, so Hadoop, HBase, Oracle NoSQL. So we've provided the graph data management and graph analytics on that. So this is the context of the session today. It's gonna orient more toward the database, so the selection on the left there. But what's the same on both of those products, and including the cloud services, the database cloud service and the big data cloud service, is the analytics and some of the features that are here. So what differentiates us in the marketplace is, one, scalability and performance, whether we're leveraging the Oracle database or the big data platforms on that. The other key differentiator is the ability to perform graph analytics, and we'll go into detail on that, and Z will give you some examples of applying graph analytics, power of that. Graph visualization as well. I see some screenshots there of Cytoscape, which is one of the open source tools that we use. The property graph query language. Oracle is one of the only of two key graph database vendors that has support for a declarative query language on that. Then we have standard interfaces for developers that want to basically build applications on their, build a variety of analytical applications on their property graph. Graph views on relational data, and then integration with machine learning tools. Okay, next slide. So for those of you coming from a relational world, graphs may seem a little bit different. And so we wanted to sort of dispel that notion that the graphs are just another way of representing data. And in this example, another way of representing relational data. So we'll get to the why you would want to model and graph. But essentially, in this example here, we're just taking relational data, in this case, columns people, memberships, and departments, and representing it differently. We're representing it as a graph made up of nodes and links. So in this example, the people are nodes, so an example is Tom, and the departments are also nodes. And so we want to basically find out the relationship between people and departments. And we use membership. Those are the links to basically identify the relationship. And that's really the key part of graph, is performing relationship analysis or applying graph analysis on relationships that are inherently in your data, but they're not very easy to execute SQL queries on. So a way to do that is to basically remodel your relational data as a graph in order to carry out very efficient graph analytics, particularly in memory on that. And that's really what we're going to focus on here. So another deeper step into the graph data model, again, it's about nodes and links, or vertices and edges. So each vertex has a unique identifier. It could be a name, or it could be an ID. It actually has a set of in and out edges that come in and out of that. So basically it represents its location in a broader network. And then there's a collection of key value pair properties as well. The same applies for the edges. Each edge has a unique identifier. Each edge represents the heads or tails of the vertex on each end, and then the labels denoting the type of relationship that it has between those two vertices on that. And again, it's a collection of key value properties. And the reason you'd want to do this, and the reason you're seeing growth in graph data management, graph analytics, is to apply analysis or to gain business insight on a lot of big data problems, to identify influencers in a large collection of social media feeds, or for a media company to find patterns in purchasing behavior by their customers. You know, which types of customers are buying which types of products, or being able to identify or group customers basically based on their patterns of behavior, whether it's communication, things they buy, services that they opt in or opt out of. And then also for generating recommendation engines as well. So as an example, I wanted to walk through a couple of our customers in financial services. We've got Galicia in Argentina, who's essentially takes their relational data, and this is in their Exadata, and basically remodeling it as a network of products, services, people, and places. What they want to do is they want to analyze the flow of transactions between the bank, Galicia, and non-bank accounts. They want to see if some of those non-bank account services they can provide. So they want to understand where money is leaving their accounts, and also where money is coming in for a particular individual account holder. So they combine their CRM data with social media data and other enterprise data to get a better handle on the transactions that their customers and their business entities that their customers are undertaking. They want to identify high-value customers across their business divisions, and they're doing this essentially to improve their services, provide new services, and provide real-time recommendations. Another bank in the same area, Santander Rio, is doing the same thing. They are basically trying to identify money flows into prospective customers. So they model it again as a graph to be able to analyze it as a graph very efficiently, but also to, in this case, visualize those transactions going forward. And then a third use case is a Chinese provincial tax office that we've been working with for the last 2 years. Essentially the same approach. They want to model the relationships, in this case, between individuals and corporations, but the purpose is different. It's a tax office. They want to identify tax fraud. So they bring into account a lot of other data, social media, web content, publicly available, open data as well. So this use case is very similar to the Panama Papers, where they bring in a lot of non-tax or non-internal tax data and link it to that in a graph, extend their graph to be able to get a better picture of the taxpayer network in this case, in that province. And they want to understand the taxpayer relationship to other taxpayers, if company structure is associated with their directors and their shareholders, and they want to identify relevant intermediaries that may be acting on behalf of those taxpayers. So in short, they want to explore tax evasion, fraud, and if they identify something, perhaps trigger a formal case of investigation if they see something fishy. And Alan Wu will give you an example of just this use case right here, because it is a sort of a compelling use case that we're seeing more and more. And then finally, CyberNetwork modeling analysis. Again, same approach. In this case, the entities are a little different. You've got servers, you've got switches, you've got storage, you've got firewalls. Those are the nodes. And you want to find out, okay, well, what's the relationship between them and what's going on in the network? So you want to basically analyze the network behavior. So first you model it, and then you apply different types of analysis on that. Reachability analysis, for example, impact, intrusion detection on your network on that. So those are different examples that we see pretty routinely with graph data management. So what these customers are using is one of the two products. I've highlighted in red the database version of Oracle Spatial and Graph, so the property graph on the database. So we'll focus on that for this session. And so from an architectural perspective, you got the data stored in the Oracle database, the links, and the nodes. Think of them as tables. A skinny table of links, a skinny table of nodes stored in a relational database. Of course, it's optimized. And then we have a data access layer to allow application developers to query that data or fetch that data or filter the data from the database. And then the key part is the graph analytics. So we have an in-memory graph analytics tool that performs the analysis in memory. The data is fetched from the data storage layer, and then analysis or queries is executed in the graph analytics layer. Visualization can be extended through Cytoscape on the upper left down there. That's an open source graph visualization tool that created plugin, or you can use your favorite third-party web-based graph visualization tool. And then, of course, you can integrate it with other big data type of applications if you're in the big data space, using R frames to basically move the graph data into that environment or vice versa. So I'll drill down a little bit into these features, and I think in future AskTOM sessions, we're going to go into some of these specific features. But for now, this is our first one on graph. We wanted to be able to sort of lay the landscape on the key features that we have on this product. So the OLAP capability is essentially a parallel in-memory graph analytics engine called PGX. It's an in-memory parallel framework for analytics. Fetches the data from the database, but on the other product, Big Data Spatial and Graph, you can fetch the data from a NoSQL database, an Oracle NoSQL database, or HBase. So it handles the analytical workloads, while the database handles the transactional workloads here. So it's an example of in the graphic of the two types of workloads that we support. And of course, the PGX can support multiple users, multiple graphs, and it has dozens of graph analytical functions. So I'd like to just sort of illustrate some of them for you. So for those of you that are into analytics, graph analytics, machine learning, these are the categories of graph analytics that are built into the PGX package. So detecting community components, walking and ranking the graph, pathfinding, evaluating community structures, link prediction, and other specific type of graph analytics. And these analytics algorithms are being extended with each release. So as we get customer feedback, we incorporate new analytics to help them support their different functionality. And of course, on the right side, we can mutate the graph. We create different types of graph. We can filter the graph. We can sort. We can create by part type graphs as well. One of the powerful functionalities of PGX. I mentioned earlier is a property graph query language. This is a declarative query language for graphs. So this allows us to issue more expressive queries on your graph data, whether it's through PGX or on the database, to get powerful results, as opposed to extending just the API layers. We have the API layers and this PGQL. And this is being introduced into the ISO community for standardization as well. These are some of the APIs that are available for application developers, blueprints, Gremlin, Rextra. Those are very common in the Graph community, Graph database open source community. We've got a Groovy shell, REST APIs, and of course the PGQL that we just mentioned. And then in graph analysis, visualization is very important because the relationships between links and nodes is very intuitive, and you want to be able to see that relationship rather than just getting results, table results, for example. So we've built in integration with a variety of third-party visualization tools. Out of the box, we provide a plugin for Cytoscape, which is a graph visualization tool, open source graph visualization tool. But there's a number of commercial graph visualization tools as well that have integration as well. So Linkurious, Keylines are very powerful libraries, JavaScript-based libraries to develop web-based graph visualization. And then Centrifuge is more of a graph application. And then there's additional libraries as well. Provided a Zeppelin front end to this for analysts that more focusing on the analytical nature of inquiry. So basically a Zeppelin, Apache Zeppelin notebook for data analysis, renders the execution results with plots, tables, and browsers. You can incorporate queries from within this browser. We've created a PGX hook for the Zeppelin integration there, a Zeppelin interpreter. So now I'd like to turn it over to Z, but before I do, I wanted to highlight one of our key resources, which is our graph blog, which is there. So this is it right here. Can you see it, Jean? Is it highlighted? Okay.
Looks good.
Okay, yeah. So this is the current blog right now, which is lists some of the developer-oriented materials there, but we've got a couple of announcements here, which we'll go into at the end of the session. But I think this is a good resource for some of you that are just getting started with this resource. There's actually a good one here, Getting Started Creating Property Graph on Oracle Database. So that's a really good example if you want to, after taking this session, be able to get started. I encourage you to take that one. There's also another Getting Started as well that's lower down on the list there. So with that, I'll turn it over to Z, who will go on with a demo illustrating what you can actually do with property graph databases.
Okay, thank you, Javier. Can you see my screen?
Yeah.
Okay, so I actually have two demos for today. So depending on how many questions we're going to get. So I will first show a text fraud demo using Graph and Graph, database visualization capabilities. And then if time permits, I will show some of the core functions in Oracle database, Oracle Spatial and Graph, property graph. Okay, let's get started. Is the font okay? The size okay? Jean?
Yeah, if you can make it a little bigger, that would help.
Okay, so I will first describe it, and when we get to the actual steps, we'll see whether it's, because the screen size changes a little bit. Okay.
Okay, great.
So this is text fraud. The setup is, so basically we got a request from a large tax department in China. The department is monitoring all kinds of, payment transactions, right, between a buyer and a seller. Okay. And they noticed sometimes there's some, suspicious activities in the data. Like, for example, if I pay, some money to a different person, that person pays the money to yet another person, and the money then eventually goes back to me. So there's a sort of, cycle or loop, right, in the pay. They tried different approaches, and they're not too happy with the performance or efficiency of those approaches. And then they came to us saying that, hey, this is our problem. Can you figure out a solution? Then we build a POC together. There are a few steps of this demo. So the first step is to, we understand the data. Right? As you can see on the screen, there are 4 blocks here. The left one shows the source data, payment data in CSV format, comma separated value. Basically, in each line, in each record, you will see a buyer. It's obfuscated. It's real data, but they sort of change the buyer name and seller name. Or the other fields are real, meaningful data. And in each record, you'll see a buyer and seller and some additional information for that transaction. Basically, we took that data, that CSV file, right? We apply one of the built-in utilities that we have. Right? This utility is able to convert from a CSV into a graph. Okay, such a utility exists in both Oracle Spatial and Graph and also the big data side, big data spatial. Now we have a graph, right? As Javier mentioned that, one can run graph analytics and the graph query. So we apply both analytics and graph query to detect such cycles in this graph. Because if you think about it, right, this circular payment is nothing but just to detect the circle in the graph. Once we detect the graph, the next step is to visualize it. Because to visualize something, visualize your data, right, you can really gain insight into the data. Okay, move on. So this is the sort of virtual machine that we have. One can use this virtual machine to play with all kinds of graph database technologies. Here we are looking at the source data in CSV format. Each line starting from here to the end of it, right? Essentially is one record of a transaction. Okay? As you can see, there's some Unicode, there's some Chinese characters. But without going into the details, the important thing is each line records a buyer and a seller and some other additional information of that particular transaction. So we're going to apply the utility, right? And then we get a graph. Okay. So the next step is to load up the graph into the graph database. Here we are showing the backend, one of the backend on big data platform. The steps are more or less the same for Oracle database as well. So here these 2 files, right? For each graph, we essentially serialize the graph into the so-called Oracle flat files. And there are a pair of files. One is for vertices, the other is for edges. Okay, we load it up using a single Java API call. Now we have all the graph data in the database. We can count the vertices. Okay. So there are about 33,000 vertices. Okay, so each vertex represents either a buyer or a seller. We can also count the edges. In this graph, in this particular graph model, we model each transaction, right, as an edge. So a transaction is between a buyer and a seller. So you have 2 vertices and an edge linking these 2 individuals. As Javier mentioned, that we have this powerful in-memory analytical engine, PGX. Right? So this graph data now sits in one of the backend databases. So we're going to read it out into PGX. By using this API called read graph with properties. So all those details you can find them on the dev guide and Java doc. Okay. So let's see the first PGQL query. Okay, we start something really simple. A loop between 2 persons. Say, John pays to Mary, Mary pays back to John. Okay, so the only 2 vertices in a cycle. Okay, so here we see an example of PGQL query. Select, so it's the first line on the screen. Select n, comma m. Well, n, point to there's a little bit of ASCII art here. to N via edge M. Okay. So if you are familiar with SQL syntax, you appreciate that there's a lot of keywords. You cannot hear the audio?
Oh, I can hear.
Chuck can hear it. Okay. Sorry, guys. My colleague just stepped in saying that she had trouble with hearing my audio. So once we run, where was I? The SQL syntax, right? As you can see in this particular PGQL query, we have select, which gives you the projection variables, right? And a where clause. In the where clause part, you define the query patterns and also constraints and filter conditions. Okay. So we run this, right? You see the bindings to these two variables, N and M. So basically individuals, right, who are participating in this particular pattern, right, from A to B and B back to A. Okay, we see very quickly within a few milliseconds, you see all those bindings. Okay, let's move on. So they're about so we just saw an example of from N to M, right? Now you want to say, hey, can I see a bigger cycle, right? So now I'm showing you from N to M to O, right? So there are 3 individuals involved and back to N. So from A to B to C, C back to A. Okay. If you look at the query, if you read it, this is really intuitive. You just define a pattern and then add some constraints. You have a select clause to define, what particular variables you want to read out. Right? It's very similar to SQL in syntax. So this result shows you all those bindings, potential values, right, to those individuals that participate in this particular sort of business activities. Okay. Now, so you have seen all those, commands, right? So the actual Java code, right? Java API calls to find all those candidates to this fraudulent activity. Now let's try to visualize them. Okay? After all, one of the key strengths of doing graph is to visualize your data. Right? So here we are using a so-called Cytoscape. It's an open source network visualization tool for which we develop a very nice plugin. Okay, so using this tool, you can talk to the graph backend database and then read out the graph data on the fly and also invoke the either PGQL graph query functions or the graph analytical functions. Okay. So here you're looking at the Cytoscape UI. This is the entry point. You define the graph name. You enter the host name and the connection information to the backend database. Okay. We are selecting this payment graph. The graph is records the transactions between buyers and sellers. We start the visualization with a PGQL query. Okay. There's many ways to start a visualization. If you think about it, when you are dealing with a brand new graph, what do? Right? You can randomly pick a few vertices, say, hey, let's visualize those vertices and do some expansion from there, right? But in this particular case, because we have a clear use case in mind, we want to detect cycles in this graph, right? So we start with the results, execution results of a PGQL query. If you look at the screen, right, there's a text box. You can type in a PGQL query in. This is the 2-hop PGQL query, right, from N to M, right? We make sure these two are not the same. So we run this query. Okay, you add all those additional properties required by this query. And as you can see now, we visualize the data on the screen. Okay, let's zoom in a little bit. So here you see 2 individuals. Their names have been obfuscated, for security reasons. Okay, and there are transactions across these 2 individuals, right? From the top vertex, right, which is one particular buyer or seller, right, to another individual, which is the bottom vertex. There are 2 transactions, 2 bought from, from the top vertex to the bottom one, and also the two bottom transactions from the bottom one to the top one. They form cycles, obviously. Okay. You can also, because this is a property graph, you can show the properties on both the vertices and edges. So now, although in this particular case, there's only a limited number of edges across them, right? But with Cytoscape, there's this nice feature called collapsing, right? You can collapse all those edges, right, from vertex A to vertex B into a single edge. Okay, this will give you a much cleaner view, as you can see now, right? To denote, right, how many edges have been collapsed into a single one, and we put a number on the edge label. So from the top one to the bottom one, you see a red edge, right, bought from, and we put a number 2 on the edge. So you have an idea exactly how many transactions are from this particular vertex to the other one. Okay. So this is a case of two-edge loop, right? Okay. So let's look at a more sophisticated case. So 3 hops, okay, from N to M to O, right? So there's 3 individuals involved in this particular activities, and then O back to N. So that form a loop. So we run this PGQL query, we find all those bindings. So this is 3 individuals participate this particular pattern. Okay. Basically, that's the result of the PGQL execution. We can expand, okay, all those transactions among these 3 individuals. Okay, so there's the one that you see the 2 vertices on the bottom and 1 in the middle, right? So now we expand all those transactions, right, among those 3 individuals. You see a beautiful butterfly. So this is one of the cool things of a graph, right? From time to time, you see really beautiful graphs. So you can see all those edges across them. So those are bought from relationships by using the same collapse functions I just described. So now we have much cleaner view, right? So as you can see, from the top vertex from this particular individual to the vertex on the right, there are 21 bought from relationships. So there's 21 transactions. Right? And if you follow the edges in red color, you clearly you can see a loop, right? A circular payment. Okay. So now you may wonder, so hey, you have found me some candidates. Those are excellent, right? But can I see, those adjacent vertices behavior from those 3 vertices, right? Let's find their friends' behavior, right? So what we are doing now is to do very simple navigation on the graph. So starting from these 3 vertices, right, on this triangle, we expand. We're pulling, adjacent vertices and edges. We do expansion. Let's take a look. As you can see, we are reading a lot more vertices and edges on the screen. Basically, we just go to the backend database, right? Say, hey, find me neighbors, right, for those 3 vertices, either incoming edges or outgoing edges. So now we have a whole lot more edges on the screen. It gets a little bit cluttered. Now let me pause for 1 sec, right, and describe what we have done so far, right? So far we have been using PGQL property graph query language to detect patterns, detect the cycles, right? Whether 2 hop or 3 hop or 4 hops, right? But it's kind of hard to say, hey, I want to detect N hops a cycle. We want to project the whole cycle, right? We don't care how long the cycle is. It could be 10, could be 11. We want to find all of them, okay? So for that kind of requirement, it's a bit hard to use PGQL because over there you have to define a sort of, exact pattern. So now we are switching to use the graph analytics, okay, to detect cycles. The algorithm we are using is called strongly connected components. Because if you think about it, if there is a cycle, right, from A to B to C, all the way to another, say Z, right, back to A, right? We don't care about how many hops, but they form a loop, so they will be in one strongly connected component. So we run this algorithm. Again, this is to use the PGX, right, the in-memory analytical engine, and it's able to then highlight all those vertices that exist in the same SCC, in the same cluster. So on the screen, you will see these three vertices, right? In this particular data set, right, there's only 3 in this SCC, in this strongly connected component. So there's no hops that is longer than 3. There's no circle that is longer than 3 hops away. So again, we are using collapsing, right, to get a cleaner view. So if you follow this red edges, right, clearly you see a cycle. The difference here is that this cycle is now detected using a strongly connected component, which is able to find circles with 3 hops, 4 hops, all the way to n hops. Okay. Hopefully this gives you an idea of this graph database, right? Graph data modeling. And also visualization. So how one can combine graph query, graph analytics, and visualization to really gain insight into the data. Okay. Any questions so far? Okay, some people want to see share the demo video. If not, I'd like to move on to the second demo. So this first demo is about a particular use case, right? How one can detect fraud, okay, potential fraudulent activities in a text setup, right? So let's move on to the second demo, which shows some of the key features of Oracle Spatial and Graph property graph. Oracle Spatial and Graph is an option offered by Oracle Database Enterprise Edition. So this is a separate option. And here we are using a small social network. It's called the connections graph, right? The data, original data, was from Time magazine a couple of years ago. Basically, they find some important people. As you can see, there are some familiar faces, right, on this slide, and also including some companies like Google, Facebook, and most importantly, the interactions, right, among those individuals and companies. Right? There are 4 distinct relationships. So here in the small rectangular box, right, you will see 4 kinds of different edges, right? There's a leads relationship, collaborates, fuse, admires. So they capture, sort of some interesting relationships in this relatively small social network. Okay. So this zooms in a particular one. This shows the collaborates and admires relationships among a few famous people like Charlie Rose, and Matthew, and even Academy. Okay. Now there are a few key steps, right, of this particular demo. The goal is to understand some of the key functions and to show some of the API calls of the PGX in-memory analyst, so some Python interface, Zeppelin interface, and a little bit of visualization using Cytoscape, right? We're going to start with, connecting to Oracle database, right? Here we are using Oracle database 12.2, and upcoming version is 18.1, which is I think is getting really, really close to release. We are going to load up the graph data using Groovy Java, right? Groovy is a nice little tool we are using to run Java code snippets. It's very convenient. Step 3 is about creating a text index so that you can easily find vertices or edges, right, of interest. Just imagine if you have a huge graph with lots and lots of different properties, right, and you want to do visualization or you want to do some graph analytics, right? But where do you start, right? So those text query allows you to pinpoint exact vertex or vertices, right, that are of interest. Step 4 is to run graph analytical functions to measure clustering coefficient, right, how tight this graph is, and also to find the shortest path, right, between individuals. And we can visualize, find top 10 influencers. Influencers here is defined as, those vertices, right, have the highest page rank value. Step 6 is to, now we have a social graph. Can we chop it off, right, into different chunks or into small communities? And the last 2 steps are using Big Data SQL to essentially we can analyze property graph data stored in Oracle database, right? And to use Zeppelin notebook, right? This is a very nice notebook environment, right? You can, in the notebook, you can type in some Java code, right? Do some code snippets, run those code, and also visualize that, right? All in the same web page. It's very convenient. It's really popular among analysts. So first step, okay. So we start Oracle database. This is a VM we have. We host this on the Relational cloud. If you are interested, let us know so we can share one access with you. The core PL/SQL APIs is called OPG_APIs. Okay. So if you install Oracle Database 12.2 or 18.1 or the upcoming 18.1, this OPG_APIs will be there, assuming you pick the Oracle Spatial and Graph option. You can describe the OPG APIs. You will see this create _PG. This is one of the fundamental API to create a property graph. Okay. As I mentioned that, we have this Groovy support, right? Here we start the Groovy script using Gremlin _OPG -OPG-RDBMS.shell. So this is in the directory of property graph on the Oracle home. Okay. You specify the JDBC URL, the logging. So this is pretty usual stuff to make a connection to Oracle database. And then we create this instance of Oracle property graph. This is one of the key Java API, okay, to use Oracle property graph function. So now we have an instance. We are using a graph config. In the graph config, you specify basically the graph name and also the database information. Okay, those are the two key pieces of information in a graph config. So now we have a connection, right, to the Oracle database. So to load up the graph data is really trivial. Actually, I have also demonstrated this, right, when I talked about the tax fraud use case. Right? You specify 2 files, one for vertices and the other for edges, right? Those two is essentially this pair, right, is the so-called flat file. With a single API call, it's called node data. This is on the bottom of this terminal. So we load up the graph data into the database. So now you can iterate through all those vertices, understand, what are the properties, what are the vertex IDs, so on and so forth. We can do the same thing to the edges. And edge, is a link between a source vertex and a destination vertex. You can also say, hey, I know a particular bank account, right? I want to find out more details about that bank, right? If you plug in the vertex ID, like I have just done, right? OPG.get vertex, right? You give a vertex ID. then it will show you the details of that particular vertex. In this case, right, this represents an individual, right, Barack Obama. Okay. So now step 3 is create a Lucene text index. Okay. We offer 2 choices. You can use either Lucene or Solr, right, for Oracle database. You can also use Oracle text index. So in this demo flow, we are using the Lucene text capability, for which we build an integration, right? So we set the index parameters, and then we denote, because if you think about it, we are talking about a property graph, and graph is flexible in the sense that, you know, for vertex 1, you may have 2 properties. For vertex 3, you may have, you know, 5 different properties, right? So when you build a text index, you need to specify what properties you want to build the index for, okay? So as you can see on the screen, we denote there are 5 properties, right? And for those values, we are going to build text index for, okay? Name, role, religion, country, and occupation. So with a single API call, create a key index, right? We create those text index. So what is happening is we read the property values, right, out of those vertices, okay? And then we build Lucene index. We invoke Lucene API call, and then we send the vertices data as documents, and we just let the Lucene build the index for us. Okay. Now we have a text index, and all this, of course, are transparent to the end users. Okay. Now we have a text index in place. One can run, you know, fuzzy query, essentially found in this graph matching vertices that are actors and located in United States or United Kingdom. So basically, we pick the keyword United. Okay. And all those matches can be found very quickly. Now let's take a look at the capability to use SQL-based analytics to find shortest path between 2 individuals. As I mentioned, right, when you're dealing with a graph, sometimes you need to find your starting point. Okay, so here we are using the text index, right, to find matching vertices. Okay, we assign them to 2 vertices, V1 and V2. Okay. And we invoke, in this case, the SQL-based analytical functions. So this function is implemented in the database. You don't really need to read the data out into PGX to use this set function. So we invoke a shortest path, and you say very quickly find a shortest path between these 2 individuals in this property graph. Okay, and then you can print out the details. Okay, so this is actually from, you know, 4 hops away from 2 individuals in this graph. Now let's move on to the next step to execute in-memory analytics, and we're going to showcase the clustering coefficient. Here we are using the counter triangle APIs. Okay, we read the graph into in-memory analyst PGX. Okay, and then with a single API call, we can find triangles. How many triangles are in this graph? You may wonder, why do we care about the triangles? Actually, this measures the clustering coefficient. So the more triangles are in a social network in your graph, the tighter, right? The tighter the relationships are. Okay, and it's actually non-trivial if you have a graph with billions of edges. It's actually non-trivial to find the exact number of triangles, right, efficiently. It took us quite a while to come up with a really efficient algorithm that can run in parallel and also scale to a huge graph. And then, as you can see, there are about 22. This is a tiny graph, so there are only 22 triangles in this graph. Okay. So we're going to use a Bellman fold. This is another algorithm to find the shortest path, but instead of finding a shortest path between two individuals, right? This algorithm is able to find all shortest paths starting from one particular vertex to the rest of the graph. This is really cool, right? Instead of finding sort of one particular shortest path, it's able to find many, many, many in one shot, okay, starting from a given vertex. I see I only have 8 minutes left, so let me speed up a little bit. So we are able to find all shortest paths from this vertex using Bellman-Ford. Okay. And then you can, of course, you know, do lookups on those shortest paths. Okay. Okay. Let me show you the influences. Basically, is analytical functions. One of the analytical functions called PageRank. I'm sure everybody is using Google, you know, every day to search, right? And one of the key algorithms behind search, behind the ranking, is PageRank, right? There's so many matches, right? You know, whatever keywords you type in, okay, there will be many, many matches, many, many web pages containing that particular keyword. But how do you rank them, right? The actual algorithm is called PageRank. And you can do Google search, right, to find the details about this one. Okay, so what I'm showing here is the same cytoscape visualization. But the difference here is instead of starting the visualization from a PGQL query or from some random vertices, we're going to start the visualization from the top 10 influencers. So those influencers have the highest PageRank value in this graph. So we're going to basically put the first of all, of course, we enter the database information, and then we put the number 10 here to say, hey, start the visualization from those top 10 vertices. Okay. So those 10 green dots are actually the influencers in this graph. And then you can expand those vertices, right? Let me just quickly go over some of the, go over the rest of the steps, okay? We also have, in addition to the Java APIs, we have Python wrappers, okay? So from, this is a Jupyter notebook. In this web page environment, you can run sort of Python code. You can also run Java code using JPipe. Okay, here I'm showing an example of using a graph community detection. And we can then plot out the distribution in the same web page. So in all those blocks, in all those paragraphs, you can, using the Python wrapper that we offer out of the box, you can also run Java APIs using JPipe. Okay. So just to give you a flavor of this. Finally, I want to show the Zeppelin notebook environment. So there's some setups, and then this is the Zeppelin interface. You can start the interpreter, right? You declare the PGX and interpreter. So now I'm going to use the Zeppelin interface, right, to talk to the graph starting Oracle database. It's the same social network connections graph in Oracle database. Okay. So we create a graph configuration, and then in the middle, the font is a bit small, but essentially the API is to read the graph into in-memory analyst. Okay, and then we run a PGQL function, a query. This query is to get a sense of different relationships, right, and their presence in this graph, to count them basically. There's a few different ways to visualize the results. One can see them in a tabular form or in different charts. You can see a pie chart or bar chart. So all of them are possible in a single web interface. Okay, you can also run analytical functions and also show them right on the screen. Okay, with that, I'm going to end the demo, and we have 4 minutes left, so we open up for questions. any questions? You can type in the chat or.
Yeah, so Z, there's one question there on how long did it take to build the Chinese example for fraud detection, if you have, if you remember off the top of your head in working with that group.
The graph modeling part is pretty straightforward, right? Because if you think about it, an edge, right, is between a buyer and seller, okay? So graph modeling part is very quickly done, right? And then we load it up into the database. That part is also very quick. Yeah. Writing the PQL query is also very quick, right? End to end to O, back to N, right? It took us a little bit time to build the visualization, right? To really to customize the visualization to show all those cycles, right, clearly on the screen. So the Java APIs, the core functions, right, took us just a few days, tops. Visualization took a few more days. If you only care about the core functions, then you can do it really quickly.
Yeah, we had a similar example that we did for Oracle Open World a couple of Open Worlds ago, where we worked with partner Tom Sawyer for the Panama Papers. That took about a week as well, and then incorporated the data, in this case, real data, Panama Papers, and then the visualization on that. So, so if you guys have further questions, we'll take those offline. You can send those to Alan Wu or to myself, Xavier Lopez. Because what I want to do is take a couple of minutes, and we've only got a couple of minutes here, just to give you some additional resources, point you to additional resources here that are available on the product. Again, the main OTN page for the products, the blog page. If those of you want to build demos, we have quite a few demos built into the Oracle Big Data Lite VM. So that's a good place to get started, including the one you saw there on the social network there, the hands-on lab there. And then we will be holding future AskTOM Office Hours. If you have particular topics you want to go into, whether it's querying, whether it's the analytics, whether it's the big data product, please let us know. We've got many ways to get a hold of us through the Spatial and Graph team, through Twitter feeds, or the Oracle Spatial and Graph LinkedIn community and Google Plus community. Also, just around the corner, we have a conference coming up. Well, there's a larger conference, the formerly known as DWATS, the Analytics and Data Summit, that's going to take place at the conference center at Oracle HQ. This is March 20 to 22. We also hold our Oracle Spatial and Graph user conference in conjunction with this event. So it's a pretty convenient event for those of you that are in the Bay Area or at headquarters. We're going to have about 10 graph sessions there taking place throughout those 3 days on that. There's going to be, in fact, a spatial and graph track throughout the whole session. So really encourage you to take a look at that and sign up. It's a very, very good event, high quality stuff there. So this is hosted by the Oracle user group, but there's a number of partner and Oracle sessions that are there. And then the day before that summit, we're going to be hosting a graph developer training day on that Monday. In the same place, the Oracle headquarters. So it's a full 3-day workshop. It's going to be organized by the Oracle product management team and developers and architects like Z to basically work you through and get you started on Graph. So there's a bit of material that's available there. Space is limited, so please RSVP to Marion Smith there on that. This session is recorded, so you can also go back to this material, these resources, if you missed anything. So with that, I'd like to, we're at the hour, top of the hour, so I'd like to thank you for joining us today, and we hope that you learned a lot, help you be more productive with property graph technologies. Please be sure to let us know how you like the session and how we can improve it in the future, and what topics you'd like us to cover. So after leaving the webcast, if you can please go back to the Office Hours page, and where you can rate the session and provide feedback. Again, for those of you, if there were questions that we weren't able to get to, please email us or provide it on the blog posting is another good place to provide feedback as well. We encourage you to come back next week, and we thank you again for coming to this session. Have a good day.
Thank you.
Thank you.